Hey everybody, this is Brad Dick saying hi. How you doing? I promised you guys some additional videos, and I've got two basically being done here in succession. And the reason why I'm doing that is because it's been a while, right? I've been repairing and redoing my garage and lab and stuff like that, so I have a little bit more cleaner environment. But at some point in time, gotta get business, you gotta get to business, and that's precisely what I'm doing now. So let me show you what I am working with. Today I am working with the HP DL 380 Gen 9 LFF and SFF chassis. And basically, this is what we're talking about. So over here is the L series. And as you can see, the big key detail here is that it's got 3¼ inch base drives, right? And these are blanks, of course. And this is for old style, but high capacity. Like, let's say, for instance, you want to get 20 or 20 terabyte drives. You want to put that in here. And this is a process stack. So with this, we have our bus array for fans. This is a bus, and these are the array of fans. An array means more than one. And these are push-pull fans. These are really nice. I like how that works and functions. That makes a big difference. Then we have here the actual shelter shield for airflow control, which is the plastic seam set here, as you can see. And then here it has the 26 series processors in here. And these are basically functional. They have all the capacity you need with them. And then as you notice here, the bays are empty. I'll explain that later for memory. Then over here, you can see it has the SAS interface. We're using port 1 only. That's all it needs. And if you look back here, you can see the bus interface. Now, the bus cardboard is not here. That's okay, because I didn't get this to run those drives. Now, if you look very carefully down there, you'll see there is one set of bus connections. All right, there. A little black header there. And that allows you basically to put the first bottom tray of drives in to provide general connectivity. So when this unit was in use, it only had 4 drives in it that were functional. But here are the bay sets that allow you to be able to put the other additional units in, just like you see here. And of course, you may also want to just take this sub-baseboard out and put in its place the full daughter bridge card, which will allow you to use both ports on board. Now, something else that's here is the RAID chipset, which is right here, and it's onboard set. It also has additional outputs here for future needs, and of course, as you can see, the PCIe standard bus here. This is 3.0, and this is 3.0, but this is a 3.0 standing. This is a support version. The ports are a little bit less functional. And of course, down here we have the expansion base set where we want to do that, which will lead us to the back part. Now, you notice here, there's this over here, and I like this because this is for a 2.5-inch media base slot that allows you to bus in connections, and you can run it over into one of these other connections. And that's a very feasible way of providing that. And the base set is empty for now. I am going to get one, but I'm not going to put it on this one, and I'll explain that later. So in the back, we have our basic USB input. We do not have our output set because the data card is not present. And of course, we have our typical 4 1 gig connections, USB and VGA output, 500 watts. That's important. The lower wattage requirement is one of the reasons why I'm getting this. And I want to use this as my next gen. But overall, this is a very good airflow design strategy. It's a little bit better than the Dell model, but the blanks are not here. I'll have to talk about the blanks later. Blanks are what would go into the slots that are not in use, but I do happen to have some extras, so that's not going to be a problem. So, what does this look like if we are pursuing the 2.5-inch SFF version, which is this? And as you can see, here's the 2.5-inch drive slots. They have blanks in them right now, and that's okay because I don't want anything in there but blanks. I have a 2 bay slot that are ready to go for 3 of these. This is an 8-bit module set. In other words, it can actually do 8 drives in the base set. And if you look behind, you will see the busing interface right here. And that runs over to right there. And again, same as the other motherboard, the dual slot 2, or if I wanted to put in another 8-bay slot here and or even a more. Now, the key detail here is that these bay slots have function, right? And what do I mean by that? And this is the reason why I am going to use this chassis with the guts of that chassis going into this one so that I can accomplish a lot more. Why is that? Well, 2.5-inch form factor works better for the NVMe model tests that which I do, and they fit fairly well for what I want to work with, so that's the first valuable thing. Secondly, these bay sets are empty. I can put anything in them I want, and for instance, I'm going to put this guy right here into that bay, or I might put it in the middle, and I might put a performance fan controller module in here. I might not. I don't know yet. But another important difference is that if you look behind the bay slot, you will see what appears to be lithium-ion batteries right there. And you can see the yellow tubing of the batteries themselves, which are right there. This is in support of your RAID configuration, so you can have the chance to be able to write. You have enough power to write your data quickly enough through the SAS cables and onto the drives before power is lost. So again, this is a better chassis between this and the other unit. Now in the back, I also have no drive bay, but I'm going to replace this with a drive bay, so I'll have 2 additional 2.5-inch disk drives in there. And with this chassis came along an additional quad set card, as well as an HBA set down here at the bottom. And I have not had a chance to inspect that, but that is, it looks like to be a QLogic HBA, so it's going to be a SAN-based connection. Again, there is no extended module for remote management. There is USB, 4-quad, and VGA. Of course, I will be putting a 10 gigs card in here and run it in 10 gig so that I can have my stress system that I need to do the work. Now, currently in the airflow here, you'll see one memory module here and one memory module here, but these are 2620s in here, and that's not good. Over here I have 2680s. Now these are 16s opposed to my 10 cores over here, so I can only get 20 out of this, or 40 hyperthreads. Over here I can get 32 or 64 hyperthreads out of these two, so I'm moving the processors out of here and I'm going to put them over here, and I'll move these lower end ones over here, and I will sell this chassis. It's still a good chassis. It's very functional. It's a very, what we call entry-level design implementation, and I will sell it for probably $100 or something. And but I will probably remove one of the power supplies so I have a backup for this one, which will go into my lab. So I'm not that interested in power consumption ratio. I want lower power. I want balance. I have the extended logic call set here, as you can see, but I'm going to pull the tray slot out of here and put it over here. And then move this one, this guy right here, over into here. And this will allow me to be able to do quite a bit. So that's value added, and I'm basically taking the best values and virtues from the 3.5-inch LFF standard configuration and moving them over into the SFF footprint, which will allow us to be able to get as much maximum return as possible. Super valuable and super good. Overall, out of the Gen 8, Gen 9, Gen 10, I'm not a fan of the Gen 10, but I do like the Gen 9. That's why I picked this. But yes, I had to buy 2 of these to make the monster I really want. And as well, do some subcomponents. Now, this leads to something else that's very important. Understanding that when you're doing this, there are two values. Buying a server out on the internet is valuable. It really is, because you can save money. But you also have to optimize the server. When you get these companies that sell these in bulk, they sell them pretty cheap, but they know what they're doing. They're removing most of the RAM. They're doing everything they can to try to nickel dime you so that you can get those extra components. Don't fall for it. Buy your chassis in the clear. Don't buy anything else from them. Get out there and itemize the part numbers of what you're needing. For instance, as a great example, these little guys. There are people out there who want to charge you $80 for these. $1. See what I mean? They have part numbers on them, if you look at them, and every part and piece is a resource. For instance, right here, this is a DVD multimedia insert tray, and then on the side, there it is. So if you do your research, let me flip it upside up so you can read it. If you do your research, you'll be able to get these subcomponents at a super low price too, because people are trying to get rid of their stuff and they want to sell it to try to get some of their money back. So do it on the low. That's fine with me. I don't know about you, but like I did, I actually found it was cheaper to buy two $100 chassis to save me $150 extra if I had to buy all the extra components. So by cheating a little bit in this process, I'm able to actually do quite a bit in regards to the output. And one of the reasons why I'm saying that, for instance, look at this. You see, when I'm on this chassis bus setup, I noticed my extended power outputs and these daughter set cards, and here as well as some other firmware checks that I want to do. Now, I don't want to reinvent this, right? So I want to do something realistic. I want to take these parts, and this is still a perfectly functional unit, and I'm going to bring them over here, put them on board with this system instead, and I'm going to be able to put that card setup that gives me the extra power outputs that I need. So if I want to put like data mining or something like that, I can, because now I have data outputs, as you can see here, that will allow me to do that. See what I mean? This is not cheap. This can almost cost you as much as this entire chassis, but buy the chassis and get the spare parts that you need. And I'm not a big fan of having a chassis for a chassis, but once you got everything you want out of it, and it's still a functional unit, then you sell it. I'm going to be doing a tech garage sell-off here soon, and that's going to allow me to be able to recoup some money locally, and that's cool with me. I like that idea. And that gives me the ability to do a little bit more, you know, and accomplish a little bit more functional stuff that I want to do. And I did that on the low. Now it takes time and it takes effort. It took me about a month to find the right units and the right kind of play that I wanted to make this work. But like I said, I mean, this was $25. They usually go for an average of $85 to $90, but I found it cheap. And I even bargained for that as well. Now, the last thing I have not done yet, but I will do, is I will take the time to get caddies for this, because I have plenty of hard drives, but I need blanks, the new 9 generation blanks. I'll get caddies for this, and I'm also going to get another component, which is of course going to be RAM. And I'll match what I've got here, so I have a consistency and footprint going forward. Outside of that, this video is to just basically tell you that when I look at these systems, they tell me that basically in a nutshell, I like what I'm seeing. And out of a 1 out of a 10 level rating, I would give this an 8.5 for the SSF. I would give the LFF probably something more like a 5.5 and 6, because there are some logical components they did in it that just doesn't quite jive, if you know what I mean. It's not a bad thing, but it's just something that I consider to be an issue going forward. Now, the last thing you can do with getting a second chassis to steal the parts you want to put into the other chassis to make a really seriously nice machine is to understand that you need spares. Spares in fans and spares in power supplies. So with that being the case, I'll remove 1 power supply from the LFF and 2 of the fan sets from the LFF and keep them in reserve for the SFF chassis. I think I've got that right. I could have it backwards, but I think it's the correct correct ID on it. Correct me if you see I have it wrong or I got it backwards. It happens. I'm dyslexic. So with that being said, I endorse the Gen 9. It's still mostly an independent chassis. I will do a logical review of the BIOS and the load processes for the environment, but I won't have any hard drives yet to play with. But I will be able to do a little bit of NVMe tricking. Yeah, that'll be nice. It's a little fragile, but it'll be really cool. You'll like it. And if you look up my NVMe to 2.5-inch video presentation, you'll see what I'm talking about, because that is some pretty cool stuff, actually. I think you'll enjoy it. Well, this is Brad Dyke signing off. I hope you enjoyed this. Trying to get back into the swing of things. My lab is still in pieces and parts, so that's why I'm out in my garage. But I said, what the heck? Let me go ahead and show this off, because I know this is what I like to do too. So God bless and have a great week. Take care. Bye-bye.